Hello everyone, myself Karthik Kumar. Today we are going to see a topic on aircraft icing. Icing factors: liquid water content, temperature, droplet size, and the cloud type, aerofoil geometry, airspeed, duration of the exposure. Where is ice likely to occur? Now you can see this image. Now you can clearly understand where the ices are forming. Icing risk: most icing tends to occur the temperature between 0 degree to 20 degree Celsius. 50% occurs between -8 to -12. Heaviest icing usually found in a slightly above the freezing level of water droplets in the clouds. Causes of icing: it is not caused by ice in the clouds, but caused by supercooled liquid water droplets. It strikes the leading edge of an aerofoil and freeze an impact. For the icing occurs, the aircraft must be fly through visible water such as rain or cloud droplets. The temperature at the point of the moisture strikes the aircraft must be 0 degree or colder. The aerodynamic cooling can lower the temperature of an aerofoil to 0 degree even though ambient temperature is few degree warmer. Icing types classification. Types of icing: clear, rim, mixed. These are classified based on a structure and the appearance of ice. These types of ice varies based on atmospheric and flight condition which it is forms. Now you can clearly see this in image how the ices are formed. Clear ice: the glossy transparent ice formed it is relatively slow freezing and supercooled water, often contains air pockets that result lumpy translucent appearance. Clear ice is dense, harder, and sometimes more transparent than rim ice. How it is formed: the temperatures are closer to freezing, larger amount of liquid water are present in clouds, high aircraft velocity, large droplets are present in dense cloud. Clear icing mostly like a building of clumps. Rim ice: roughly milky and opaque ice, it is called as rim ice. The formation of instantaneous or very rapid freezing of supercooled droplets as they strike on the surface of the airfoil. It freezes between the drop has been trying to spread. Rapid freezing results in the formation of air pockets in the ice, giving an opaque appearance and make it as porous and brittle. For a larger acceleration, rim ice may form streamline extension of the wing. When it is formed, temperature are low, low amount of liquid water present, low velocity, small droplets are present. Mixed ice: mixed ice is a combination of clear and rim ice, and the shape and roughness of the ice is most important aspect for an aerodynamic point of view. Now you can see this image where are all ices forming in an aircraft. Icing in a communications: because the smaller size and shape of antennas, they do not lay flush with the aircraft skin, tend to accumulate ice rapidly. Ice accumulation may cause antenna to vibrate, radio signals become distorted, damage to the antenna. If the frozen antenna break off, it can damage the other area of the aircraft in addition to cause a communication or navigation system failure. ice weight impact. The weight of ice may prevent an aircraft taking off, maintaining altitude, significant alter the CG. How much ice can non-approved aircraft carry? It, it is unknown. It is what never determined through the testing. Fuel system icing. In during flight, the temperature of the fluid tanks is decreased due to the decrease in temperature at altitude. The temperature decrease causes precipitation of dissolved water from the fuel. The separated water droplets from the tank because of denser than the fuel. Since the water is no longer solution, it can freeze, blocking the fuel inlet pipes and causes the fuel it reduces the fuel supply. The entire water will freezes in chloride fuel and tend to stay a solution longer since the specific gravity of ice approximately same as the aircraft fuel. Ice crystals begin from the entertainer water in fuel and temperature nears the freeze point of water. Due to the impurities of the water, normally this takes place slightly lower than 0 degree to minus 1 degree. As the temperature decreases further, ice crystals begin to adhere to the air surroundings and it forms ice. At the temperature between 0 degree Fahrenheit, ice crystals tend to become larger and can plug small openings such as screen, filters and orifices. De-icing and anti-icing equipments. Anti-icing equipment is turned on use before entering the icing conditions. It includes carburetor, heat pump and probe heater, pitot heat, fuel vent and windshield, etc. etc. De-icing is used to alter icing as build up appreciable amount typically includes surface device equipments. There are two types of anti-icing systems. Weeping wing system pump fluid from the reservoir through the mesh screen embedded the wing leading edge to trailing edge. Heated wing. These typically found in jets. Windshields. Two systems used to in light aircraft. Electrically heated windshields, fluid de-icing spray on the engine. Icing can also controlled by very limited extent within the windshield defroster. Never acceptable by itself. On many aircraft, the only source of windshield is ice prevention. Unprotected area of an aircraft with an de-icing equipment can still having a significant performance on impact even after use of equipments. Close to the 30% of total drag associated with the ice encounter remain after all the protected surfaces were cleared. Non-protected surfaces may include antennas, flame hinges, control horns, fuselage and windshield wipers. What about using anti-icing fluid? The consultant your pilot operating handbook for the specific information. General guidance. Key factor is the rotation speed. Rotation speed of 60 knots normally considered type of fluid. Type 1 fluid, orange in color, mostly glycol. Production time is limited to 5 minutes or less. The rotation speed is 60 knots or more than be able to use the type 3 fluid if approved with the airframe manufacturer. If only rotation speed is 110 kiloknots, knots or more, you should consider using a type 2 or type 4 fluid, and then if it is approved by your airframe manufacturer. Ice avoidance flight plan. Very easy to predict where the larger areas of ice potential exist. Accurate prediction and specific icing areas altitudes are much harder. Hard clouds are like there are dry clouds and wet clouds. Front and low pressure areas are the biggest ice producers, but isolated air mass instability within the plenty of moisture can produce significant icing. Freezing rain and drizzling are very dangerous. For a VRF planes, exceptions of freezing rain, freezing drizzle, and carburetor icing, staying clear and clouds are safer margin generally will prevent the ice formation. Carrying the extra fuel in icing condition, extra power is needed to because of increasing aerodynamic drag or because of carburetor heat is used. Removal of frost snow from the wing to count on blowing snow off, taking off. There could be a nasty sticky stuff underneath snow. Check for ice and snow elsewhere. Propeller dry and clean. Check the controls to be sure that full freedom movement in all directions. Check the landing gear and clean off all actuator slashes. Thank you all.